5, 4, 3, 2, 1.
Good morning, everyone. Our project is titled Automated Line Drawing Extraction, and our group name is PlotBot. The goal of this project is to build a computer vision pipeline that converts real-world images into clean line drawing using classical image processing technique. Instead of using deep learning model, we focus on fundamental computer vision algorithm to extract the important structures of an image. Today, I will explain the problem, system pipeline technique, and the result of our approach. First, let me briefly explain the project overview. In real-world photograph, there are so many elements such as color, texture, shadow, and lighting variation. These details are useful for humans, but can make it difficult to clearly identify the main structural feature of object. So in this project, we develop pipeline that transform photograph into simplified line drawing similar to sketch style image. To achieve this, the system extracts important control boundaries while removing unnecessary visual information like color and noise. This pipeline uses several classical computer vision techniques, including grayscale conversion, Gaussian smoothing, edge detection, morphological operation, and thresholding. The final output is a clear black and white sketch, and also any other art style representative of the original image. The main problem we address came from the complexity of real-world images. Images are captured by cameras usually contain complex color, lighting, and background noise and unnecessary texture. This feature make it difficult to directly extract meaningful structural information from images. For example, if we want to identify object boundary or shapes, this extra detail can interface with uh, the detection process. Therefore, the challenge is to simplify the image while preserving the important structural feature such as add and control. Based on this problem, our project has three main objectives. First, we want to remove unnecessary details such as colors and noise that do not contribute to the structural understanding of image. Second, we aim to highlight the most important contour and edge, which represent the shape of the image. Finally, we want to produce a visual clear line drawing, which is easy to interpret and resemble a sketch or technical drawing. This objective help demonstrate how basic image processing technique can transform complex images into simplified visual representations. There are several reasons why we choose this project. First, it clearly demonstrates the core concept in computer vision, especially image processing and feature extraction. Second, our approach do not rely on deep learning model or pre-trained model. Instead of focus on algorithmic understanding, which help us better understand how classical technique work. Third, the results are easy to visualize and evaluate because we can directly compare the original image with the generated sketch. Finally, this type of technique has real-world relevance in areas such as digital art, animation, and architectural sketching, and also image styling. We especially choose this pipeline because it is simple, fashion, and educational. The method we use in this pipeline are fundamental computer vision technique, which is widely used in many images processing. Another advantage is that there are techniques do not require large dataset or expensive training process, unlike a deep learning approach. The pipeline is also computationally efficient, which means it can potentially run on real-time application. Finally, the process is easy to understand and visualize, making it suitable for learning and experiments. To build our system, we selected five main techniques. First, grayscale conversion, which simplifies the image by removing color information. Secondly, is uh, Gaussian smoothie, which produce noise and help stabilize agitation. Third is agitation, which identify the boundary and control of image. Fourth is morphological filtering, which strengthen and connect at. Finally, we apply thresholding, which help produce a clear binary image representing the sketch. Together, these steps form a complete pipeline that transforms a photograph into a line drawing and some other art styles. So this is our system pipeline. This system pipeline shows like the processes start from an import image of a photograph. The second, this one is like a grayscale conversion and noise reduction, detection, morphological processing, thresholding, and final add output. So this will be our flowchart. You can find like when we got the images, we will like our system will do some kind of processes, some kind of computer vision process here, and then we have four feature, which is like the choosing the art style. The first one is art arts. The second one is basic sketch and also cartoon and the wine painting. We can choose this for art style and then we got the result from it. So here is like classical computer vision process, Gaussian blur, and also like detection, morphological processing, and thresholding, something like this. So the project demonstrates the importance of computer vision process. First is image processing, which prepare the image for further analysis. Second is grayscale transformation, which simplify image jitter. Third is Gaussian smoothie, which reduce noise and stabilize agitation. Fourth is agitation, which extracts meaningful structural information. Fifth is thresholding, which convert the image into binary representation. Finally, we use morphological operation, which refined uh, the ad and improve visual clarity. Together, these techniques, we can illustrate how classical computer vision algorithms work together in a pipeline. So let's move to our demonstrations. So here, so here, we can upload any images here. An image. Okay. So you can choose the art style. So first one, add as like this here. So you can download it or you can also zoom out the image. And then I will change the art style here. Cut off. It's like this. Okay, for cartoon, so the art style here. So you can change the art style and then submit it and also download.
Hello, so I'll be now presenting from here. So this is my part from slide 9 to slide 16. So I'm Calvin Chetri, section 1, RAI. And what I did for this project is I did the coding part and implemented certain functions so that we can get a proper results. So parameters for each technique is first thing first, preprocessing is like basically saying grayscale, like turning RGB to gray so that it can be easier for us. And then we do some noise using Gaussian blur. We set the kernel to 5x5, which is the kernel to 5, and sigma is 0. Edge detection, for detecting the edges, we use the Canny function, and you see the min, max, the low, min, and max. You see 50 and 150. And morphology is dilation. We use dilation, and we set the kernel to 2, and we enhance by using bitwise inversion, which basically reverses the color, which was black in the background and turns white. Okay, now code implementation is like what I said earlier. So like first thing first, we turn into RGB, BGR to RGB. Then we turn into grayscale. After turning into grayscale, we use Gaussian blur to reduce some noise, and then we detect the edges. So after using Gaussian blur, detecting the edges will be much more smoother. So yeah, so and then morphology, well, for morphology we use NP, which is numpy, and yes, we set the kernel to 2 and we dilate instead of using another functions we use cv.dilate, and the final results we use bitwise. And this is the result first. You see the original image first out here. So and then this original image is converted to pencil sketch, and then it can also be converted into cartoon, converted into oil painting. And but what we wanted was a pencil sketch so that we can implement this pencil sketch into something else. And applications as in where can I apply this project, like where can I use this kind of techniques, where can I use this method in future or wherever I want. So I can use this for digital illustration, animation preprocessing, like let's say some of the mangas is black and white, so we can use my project technique to make such mangas, and architectural sketching, which like most of the architects use, image stylization. You know how you style, like you know how you make your images, and educational visualization tools. So it can be used for education as well. Evaluation plan and limitations. How we will evaluate? We will evaluate based on visual clarity of edges. So for our after image or before, so how we're gonna do it is first thing first we're gonna like notice the visual clarity of edges. Like okay, so we have like functions and we don't know like exact number or limits to like set it on at the first. So we gotta test each and every number so that we get the perfect ones. Right now what we did is not even perfect, but we still have the desired output. Desired output. So yeah, firstly, visual clarity of edges, noise reduction effectiveness, preservation of main shapes, processing time, comparison of different edge methods. So limitations, I say, is okay. Sensitive to image quality, such as like some of the images are like rotated, some of the images are like blurred already, and if we use a Gaussian blur on a picture which is already blurred, that means it's gonna create more noise. So lighting conditions after results, so you know how lighting affects a picture, and fine textures may be lost. Yes, Canny edge detection cannot, like sometimes cannot detect proper edges. I mean, this is the best edge detection function to be used in this generation, but then it can still make some mistakes, like it can still avoid some of the edges and cannot understand semantic meaning. Proposed idea for improvement. So in order for a project to improve in the future, or if I or my teammate want to carry on this project for our future implementation, we're gonna do, it's like what improvements we're gonna make are like adaptive thresholding for better edge detection, deep learning methods for more accurate sketch extraction, real-time webcam, sketch generation, interactive GUI using Grayscale, support for multiple artistic styles, mobile or web-based deployment. Conclusion. So this is it for our project, and this project demonstrates how classical computer vision techniques can transform photographs into clean drawings. So a random photograph into a pencil drawing or makes it look like someone drew that. It helps us understand fundamental concepts such as preprocessing, edge detection, and morphological operations, like whatever I said in the previous slides. Thank you.